Hello, my dear students. Today I will be discussing about new chapter that is basic hydrology. All of us know hydro means water and logy means science. Hence, hydrology means the science of water. So, how we can define hydrology is the science dealing with occurrence, movement, and distribution of water above or below the land surface or in the atmosphere. You can also define as it is the process governing the depletion and replenishment of water resources of land areas of the earth. So, all of us know this sources of water, that is, oceans is 97.25%, ice caps and glaciers 2.05%, groundwater 0.68%, lakes 0.01%, soil moisture 0.005%, atmosphere 0.001%, and streams and rivers 0.0001%. These are the some of the sources of water. Let us see what are the applications of hydrology. Hydrology is applied to major civil engineering projects, mainly the irrigation schemes and dams and hydroelectric power projects, and also water supply projects. These are the main applications of hydrology: main irrigation schemes, dams and hydroelectric power projects, and water supply projects. So overall, how you can tell the applications of hydrology are like this: determining the water balance for a region, assessing impacts of natural and human induced environmental change on water resources, designing irrigation schemes, designing drainage systems, designing urban drinking water and sewage systems, assessing export of sediment and nutrients from fields to water systems, determining agricultural water balance, designing buffers, predicting floods. These are all the common applications of hydrology. Let us see what is the hydrologic cycle. Journey of water from the ocean to atmosphere and back to the earth and ultimately to the ocean through the process of evaporation, precipitation, percolation, runoff, and return to the ocean is called hydrologic cycle. All of you know this. This is the first process: rainfall, transpiration, infiltration, runoff, then evaporation. This is the unsaturated zone and is the water table. It is nothing but the journey of water from the ocean to the atmosphere and back to the earth and ultimately to the ocean through the different process and finally return to the ocean. That is called hydrologic cycle. Let us see one by one the precipitation. It includes rain, snow, and other forms of water falling from the atmosphere into the land and oceans. And evaporation, physical process by which water is vaporized into the atmosphere from free water surface and land areas. Transpiration: water from the soil is absorbed by plant roots and eventually discharged into the atmosphere through little pores in the leaves called stomata. Evapotranspiration: combined process by which water is transferred to the atmosphere from open water surfaces and vegetation. Infiltration: movement of water from the land surface to the upper layers of the soil. Percolation: movement of water through the subsurface down to the water table. Overland flow: portion of runoff that travels over the surface of the ground to reach a stream channel. Surface runoff includes all overland flow as well as precipitation falling directly onto stream channels. These are the different components of hydrological cycle. Let us go one by one. The first one is the precipitation. All types of moisture reaching the surface of earth from atmosphere. Precipitation is the basic input to the hydrology. Ocean surface is the chief source of moisture for precipitation. Okay, this is the process of precipitation, condensation, evaporation, then these are the lakes, surface runoff, groundwater. This is the groundwater. So here there are different forms of precipitation: dew, mist, fog, rain, hail and snow. Let us see what is the rain. Here all of you know this. This is the most common type of precipitation in our atmosphere. Rain is the liquid droplets fall into the surface of the earth. There are two different forms of rain, either in the form of showers or drizzles. Showers are heavy, large drops of rain and usually last a period of time. Drizzles, however, usually last longer and are made up of smaller droplets of water. Rain can either be formed as ice crystals melt or it can be smaller water droplets. This is the intensity of rainfall. If it is a light, I is equal to 2.5 mm per hour. If it is moderate, then it is 2.8 to 7.6 mm per hour. If it is heavy, it is I is greater than 7.6 mm per hour. Snow, can see here. Snow is the second most common precipitation in the northeast. Snow forms when water vapor turns directly into ice without ever passing through a liquid state. This happens as water condenses around an ice crystal. Average density is of this is zero point 0.1. Next is hail. Hail is created when moisture and wind are together. Inside the cumulonimbus clouds, ice crystals form and begin to fall towards the surface of Earth. The shapes of hail particles are spherical, conical, irregular. Diameter ranges 5 to 125 mm. Specific gravity is 0.8. Average density is 0.1. Fog, there is really no difference between fog and the clouds that are high in the sky. In simple terms, fog is a cloud that has formed near the surface of the earth. There are four main types of fog: radiation fog, advection fog, upslope fog and evaporation fog. Dew, the small drops of water which can be found on cool surfaces like grass in the morning. This is the result of atmospheric vapor condensing on the surface in the colder night air. Mist or drizzle. Mist is a bunch of small droplets of water which are in the air. This occurs when cold air, when it is above a warm surface, for example, water. Fog and mist are very similar. The only difference is their visibility. Diameter ranges between 0.1 to 0.5 mm per hour. Glaze. Glaze is the ice coating, generally clear and smooth, formed on exposed surfaces by the freezing of supercooled water deposited by rain or drizzle. Glaze, also the specific gravity is as high as 0.8 to 0.9. Rime. Rime is a white opaque deposit of ice granules more or less separated by trapped air and formed by rapid freezing of supercooled water drops impinging on exposed objects. Specific gravity may be low as 0.2 to 0.3. Sleet consists of transparent, globular, solid grains of ice formed by the freezing of raindrops or freezing of largely melted ice crystals falling through a layer of sub-freezing air near the Earth's surface. Then there are different ways of measuring the precipitation. The most common types are amount of precipitation, intensity of precipitation, duration of precipitation and areal extent of precipitation. There are different methods to measure the precipitation. Precipitation may be either rain, or snow, it can be measured by various devices. Some of the measuring devices and techniques are as follows. The first one is rain gauges, snow gauges, radars, satellites, scratching of snowpacks, water equivalent in snowpacks. These are the common methods of measurement of precipitation. Let us see first rain gauges. Rain gauges are most commonly used for the measurement of precipitation, both in terms of rainfall and snow. Types of rain gauges. There are two main types of rain gauges which are used to measure the precipitation. These are non-recording rain gauges, or it is also called as non-automatic rain gauges. Second one is the recording rain gauges, that is automatic rain gauges. Non-recording rain gauges. It is a rain gauge which does not provide the distribution of amount of precipitation in a day. It simply gives the amount of precipitation after 24 hours. It is daily precipitation. Okay, Simon's rain gauge is the instrument prescribed by all government rain gauge stations throughout India. This is the instrument of non-recording rain gauge. Recording rain gauges. These rain gauges are also called integrating rain gauges since they record cumulative rainfall. In addition to the total amount of rainfall at a station, it gives the times of onset and cessation of rains. Thereby, it gives the duration of rainfall events. Types of recording rain gauges. Okay, there are different types of recording rain gauges. Most commonly used methods are weighing bucket type rain gauges, tipping bucket type rain gauges, and flow type rain gauges. The next class will study in detail what are the principles of weighing bucket type rain gauges, tipping bucket type rain gauges, and flow type rain gauges. Thank you.